Hello everyone, myself is Divya Bahal, Assistant Professor in Chemical Engineering Department at LJ Institute of Engineering and Technology. The subject that we are going to continue is petroleum refining and petrochemicals. So this chapter is about studying about the various properties of your petroleum fraction. So now we will talk about residue. Okay, what comes into residue? It is your bitumen. Now you can see the sole purpose of bitumen is mainly used for the roads and roofs construction, right? Now here you can see as we go bottom the distillation column, right? Large molecules are there. Okay, the molecular weight of your hydrocarbons is very large. That constitutes for the high boiling point. Okay, not very volatile. Of course, it's not at all volatile. It's very less volatile in nature. It does not flow easily. Viscosity increases up to very high extent as we go bottom the distillation column. Okay, your product gets more and more viscous now. Does not ignite easily. So these are the properties of your heavy components. Now bitumen being the last component you get into it, you can imagine its viscosity. Okay, its volatility. It's very less. Hence making its boiling point very high. So talking about bitumen, let's look into its physical properties. Okay, first of all, it is the residual product obtained in the crude distillation unit. Residual means it is end product. Not anything can be extracted out from it now. Okay, so that is the residue part of your crude. Okay, it is now highly rich in non-volatiles. Okay, so it is solid at room temperature. It has very high viscosity. As discussed earlier, it is the bottommost part of the crude distillation unit. Hence, it is very heavy in nature, making the viscosity very high. Now, asphalt. What is asphalt? It is the mixture of bitumen with high mineral matter. Okay, if the content of mineral matter is very high in your bitumen, it is also called as asphalt. Okay, now what are the mineral matters we are talking about? Your mineral matter is what? Inorganics like sulfates, chlorides, carbonates. Okay, these are minerals, right? So asphalt is what? It is bitumen rich in these minerals. Okay. Now what is the use of bitumen? It is mainly used in highway construction, waterproofing and coating work. Now viscosity index. As we are talking about the residue fuel, okay, we discussed earlier also that viscosity increases as we go bottom the crude distillation unit. Okay, so viscosity of your lubricating oil like lube oil, bitumen, these are what. Now here viscosity is very important factor because flow characteristics has been almost ceased here. So what is viscosity index? It is an arbitrary unitless measure of fluid's change in viscosity relative to temperature change. Now this is an again empirical formula is obtained here, okay, which relates change in viscosity with change in temperature. Okay, it is mainly used to characterize the viscosity temperature behavior of your lubricating oils. It is important for bitumen also, but this property is mostly important for lube oils. Okay, because here we are talking about the lubricating property. Use of lubrication is where? It is used where the friction generation is most. Okay, lube oil, what does it does? It helps, it aids the lubrication between those friction so as to reduce the heat formation. Okay, so as to reduce the heat generation which results because of friction. So hence viscosity is important. Because of friction, what is happening? Your temperature change occurs. So because of that, viscosity is important parameter which we have to deal with. Now, note down the important result here. The lower the viscosity index, the more is the viscosity affected by change in temperature. So you have to remember this rule. Low viscosity index means your viscosity is highly affected with temperature change. Okay, it is very sensitive to temperature change. Little bit of temperature change can change your viscosity up to very high extent. It is the meaning of lower viscosity index. So you can see viscosity versus temperature graph. Okay, so here you can see the viscosity versus temperature graph. The blue line, it indicates low viscosity. You can see the slope is very high. Large slope means what? Low viscosity index. So I can get a new relation here. Higher the slope, okay, larger is the slope, it means lower is the viscosity index. And what is the meaning of low viscosity index? That your viscosity is affected by changes of temperature. So see, I have divided my some certain fractions here. So you can see very high viscosity index up to, you can see 140. As I told earlier also, it is a unitless measure. So this empirical number is what? 140. It is for synthetic oil. So you can see the slope is very less. It means viscosity index is high. The effect of change in temperature is moderate. Second one is high viscosity index, you can see, of the mineral oil. Okay. And last is the low viscosity index for naphthenic crude. So you can see the slope is very large. It means it is very sensitive to temperature changes. So the common lubrication test is ASTM D2270, right? So what do we do here is, your viscosity index of an oil is calculated from its kinematic viscosities at 40 degrees Celsius and 100 degrees Celsius. So we have two parameters, one at 40 degrees Celsius test and at 100 degrees Celsius. So your high viscosity index oil, okay, what is that category? Oil exhibits small decrease in kinematic viscosity with increase in temperature. What is kinematic viscosity? It is ratio of viscosity of your oil upon density of your oil. Okay. High viscosity means your oil exhibits small decrease in kinematic viscosity with increase in temperature. Low viscosity index means your oil will exhibit large decrease in kinematic viscosity with increase in temperature. So I can say high viscosity index means less temperature sensitive, low viscosity index means high temperature sensitive. So paraffinic oils, the range is 80 to 100. Okay, the viscosity index range is 80 to 100. Naphthenic oil means low viscosity index 0 to 30. So it means naphthenic oils are more temperature sensitive, right? So you can see kinematic viscosity versus temperature graph. Okay, so what you are doing is, here L and H. So the viscosity index formula is L minus U upon L minus H into 100. Okay. Here L and H are the viscosities at 40 degrees Celsius for two hypothetical oil of viscosity index 0 and 100 having the same viscosity at 100 degrees Celsius as the oil whose viscosity index we are trying to determine. Graphically you can see at 40 degrees Celsius, L and H are my two reference oil, okay, whose viscosity index is what? 0 and 100. And at 100 degrees Celsius, U, L and H. U is what? The oil whose viscosity index we are trying to determine, okay. At 100 degrees Celsius, viscosity index of these three oils are same. So that way, you measure your viscosity index of your known oil, right. U is what? The oil of which you have to measure the viscosity index, whereas L and H are the hypothetical oils. Moving forward with softening point test. This is one of the important tests for bitumen to know about its characteristics. Okay. This test is also called as ball and ring test. Okay. So what happens in this test is, you melt your bitumen and cast into disc. Okay. The apparatus is such that ball and ring apparatus is there, but you collect your sample, okay, your bitumen, it is melted and casted into disc. A steel ball is kept on casted disc of the bitumen. The disc in which you are taking your bitumen sample, above that you keep your ball. The whole stand carrying these two discs with balls is immersed into glycol and water bath. So what you did is, you cast your bitumen into small disc, you support it, okay, because you are suspending it into water or glycol bath, but so as to support that, you are placing steel balls over that so that it won't float, okay. Now heating occurs. What you are doing, you are supplying indirect heating, right. You are heating your water or glycol, so that way you are supplying your heat. Now because of heating, what does? Softening occurs. So here what do you try to do? You measure the temperature at which the sample detaches from the disc and falls into the beaker. So that temperature is your softening point. You can see this is the apparatus, okay, ring and ball. You can see in this disc you are taking your sample of bitumen and you are placing the steel ball above it, okay. The disc is what? To provide support to the bitumen sample, and in the suspender you can see how you are placing your bitumen disc with ball, okay. So this way, starting point and end point. In experiment, what do? You start with heating. Okay, at start point you can see steel balls are kept over the bitumen sample. As you're gradually heating, what will happen? Your bitumen sample will soften. Okay, you have to note down the temperature at which this softening point is there. It means bitumen will detach itself from the disc and fall downwards into the steel plate. Okay, so that temperature when it detaches itself, that is your softening point. Now the next test for bitumen is penetration test. Okay, this test, what is the aim of this test is to measure the hardness quality of bitumen. Okay, so in this test what do? A standard needle is allowed to penetrate under a load of 100 gram through the sample kept at 25 degrees Celsius for 5 seconds. Okay, so this you can see that what you are doing, you are just allowing the needle to penetrate. At what temperature you are keeping a sample at 25 degrees Celsius, and the duration of penetration is how much? 5 seconds. So the distance traveled will depend upon the load and the softening point. So at the end, what is the aim of experiment? To measure the distance which has been penetrated by the needle into that sample. So more the penetration index, what does it suggest? That your sample, your bitumen, it is not suitable for surface applications where hardness is important. Let's talk about surface application like making of roads. Okay, so for that is what? That is your surface application. So if your bitumen is soft in nature, then it is not suitable as a surface applicant. So that is the characteristic of bitumen which suggests hardness of it. Okay, more the penetration, it means it is soft and hence it cannot be used for surface applications. So you can see the apparatus and how it works. So at 100 gram load I am keeping. The scale, it measures in mm the penetration length, right? The scale which is shown above in the apparatus, it gives you distance travelled in millimeter. So you can see at start point, what I am doing, 100 gram of load, I am suspending it with the needle right at 25 degrees Celsius. Now, once I have suspended it, for 5 seconds, I will measure, in the scale will show you how much mm it has been penetrated. So what is that? That is your penetration index. So that was about today's lecture. Thank you.